Hi everyone, I'm really sorry that I can't be at the award event, but I have this really important conference that I need to be at. I would love to be there and see all of you, but again, I'm sorry. So I do research in pancreatic cancer. It's kind of a less well-known form of cancer, but it's a very difficult form of cancer to treat for various reasons. It metastasizes really early, and it has this really extreme deposition of collagen and other factors that make it very dense and makes it really hard for chemotherapy to actually get into the tumor. So my research is kind of focused on trying to deplete that collagen in order to relieve the pressure, loosen up the tumor, and actually allow chemotherapy to get in. So that's one of the main challenges, and that's what I'm focused on. It's been realized that rather than the cancer cells themselves being the primary point of resistance, it's actually these environmental factors, a specific type of cell that's responsible for depositing all of that collagen and hyaluronic acid. So I guess what makes us unique is that's the particular thing that we are focusing on and that we really believe is causing the elevated pressures and the primary obstacles. But other labs have looked into things like hypovascularity, which is a problem in pancreas cancer. There's very few vessels. So some labs have looked into trying to grow new blood vessels, and there's various ways to come at it, but we're coming at it in this kind of unique way of focusing on those ECM extracellular matrix components and this one particular cell type. I've been trying this one new drug called halofuginone, which specifically is an anti-fibrotic drug. It's a Chinese, it comes from a Chinese plant that's been used for like thousands of years to treat various diseases, but it's only within the last, I think, 20 or 30 years been recognized as an anti-fibrotic. So now we're trying that in pancreas cancer, and through some combination therapies that we've been doing with our mice, we have seen some really promising results in a couple of mice, but I really haven't done a lot of studies yet. So of course I need to increase the sample size and continue seeing if that's statistically significant. But in a couple of mice, it's had some really, really good results, just really nuked the tumor. That's another thing that makes our lab kind of unique, is that we're using a genetically engineered mouse model of pancreas cancer. And for a long time, cancer research has really heavily depended on these xenografts and these orthografts, which are different because they're still injected, but the orthografts will inject it into the actual pancreas, but it's not a naturally grown tumor, so it's very different. It doesn't develop the same way at all. So by using this genetically engineered mouse model of pancreas cancer, the experiments that we're doing really closely reflect what you would see in a human. So that makes it a lot more reliable. So the engineering really comes in terms of just the quantitative analysis, rather than looking at these qualitative differences from one condition to another condition, really quantifying those results. And for my project specifically, I'm a chemical engineer by training for my undergraduate degree, so I'm interested in looking how the transport phenomena is actually affected and trying to do some calculations on that. So that's where the engineering would come in for me, at least. I was in my senior year of undergrad, and I was thinking, I don't feel like I'm ready for a job. I feel like I really want to learn a lot more about this biomedical field. Like I said, I was a chemical engineer by training, and I really was interested in the biomedical applications of that. And actually, my sister was going here, which made me look at the University of Minnesota, just because I thought, well, she's there, I might as well take a peek. And I just really liked it. It was a great area. I mean, the resources that are available, with the med school and the medical device companies being so close to each other, I just thought this is a great area. It has amazing resources. It has some really, big names in terms of the professors in this department that are just powerhouses in their fields of research. And I actually wasn't sure what I wanted to do when I came in, which I think makes me kind of different from a lot of people who go into graduate school. I didn't have a really specific plan. Like, I didn't know I wanted to do cancer research, but I did my rotations, and I rotated with Paulo, and he was really passionate about this, and that really translated to me. So. Lately, I have been thinking I might stay in cancer research. It's something that definitely, I think it's the second most influential disease in our country after cardiovascular disease. And so I feel like there's definitely a need for that. And after going through all this training and all this research, I feel like I'll have a good perspective on it. So I have been thinking about staying in that more lately. So I was recruited to do the 400 hurdles. That was my primary event in undergrad. I also did some other events indoor, like relays and the 600 yard, which is like the most random event ever. But I was mostly a hurdler. The 400 hurdles is, I think the 800 would probably be harder, but most people think that the 400 hurdles is like the most difficult track and field race. And it definitely takes a lot of mental fortitude. There's a point where you have to, make a decision where, am I going to just give up? I'm really tired, or am I going to just really push through this and give it everything that I possibly have? And I do believe that mental fortitude is something that's very important in research. It can be frustrating when you're not really moving forward as much as you want to be. So just being mentally, having that mental fortitude, I think is something that has translated, as well as just having that competitive spirit, always wanting to try my best and at least expecting a lot out of myself. It's hard to compare yourself to other graduate students sometimes because everybody's sort of at a different level or a different mindset, but I always expect a lot out of myself, and if I don't do my best, I'm not happy. So I think those things are definitely connected. It's definitely, in terms of the financial aid, it's definitely opened some doors, like this conference that I'm going to, that's partially funding my way there. One thing I do want to do is maybe organize some kind of an event to raise awareness for pancreas cancer, like a walk or something. Like I said, it's a much less recognized disease than something like breast cancer or lung cancer. So that's something I want to do. But it's really opened doors to connect with some really amazing people. Especially the women in our chapter, they're, just amazing examples of leadership, and they care about science and they're passionate about that, and really perpetuating that to the next generation. And as a female and scientist, that's something that's really encouraging to see. And just not only connecting with them, but connecting with other ARCS scholars and the donors at events like this that I can't be at. But, it's really motivating, and it makes you realize that, my work is important. Like this, it just really reaffirms that. And I don't know, it's a great organization. I'm very proud to be associated with it. I believe in what it stands for.